Hello guys, good afternoon. You are welcome to my YouTube channel, the Explicit Tutorials, and my name is Tutor Joseph. In today's video, we'll be discussing Physics 111 topic vector quantities and scalar quantities. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, like I said, we'll be discussing vector quantities. What are vector quantities? They are quantities with magnitude and what direction. They are quantities with magnitude. Underneath for magnitude means what? Size. Alright, there are quantities with both size and what? Direction. What are examples of vector quantities? Please take note of it. It's very, very important. Now we have displacement. Displacement is a vector quantity. Momentum is a vector quantity. Moment is a vector quantity. Impulse is a vector quantity. Torque is a vector quantity. Tension is a vector quantity. Upthrust is a vector quantity. Okay, velocity is a vector quantity. Acceleration is a vector quantity. Field intensity, all of these are vector quantities. You also have electric field. Electric field is a vector quantity. Magnetic field is a vector quantity. Friction is a vector quantity. Which one again? Gravitational field is a vector quantity. We now have weights. Weights is a vector quantity. So all of these are vector quantities. Take note: displacement, momentum, moment, impulse, torque, tension, upthrust, velocity, acceleration, field intensity, electric field, magnetic field, friction, gravitational field, and what? Weight. All of these are vector quantities because they have magnitude and what? Direction. Now the opposites are scalar quantities. Scalars. Scalars are quantities with a magnitude or size without what? Direction. They only have magnitude or size, or they do not have what? Direction. Examples are speed. Speed and velocity have the same dimension and what? Unit. The velocity is a vector quantity. The speed is what? A scalar quantity. You have mass, volume, distance. Now, density, all of these are scalar quantities. Now, energy. Energy is also a scalar quantity. Did I give you force? Yeah. Force is also a vector quantity. Force is a vector quantity. Energy, potential energy or kinetic energy, the both of them are the fact that kinetic energy is usually that type of energy possessed by a body in motion. It is what? A vector quantity. It's a scalar quantity because the vector quantity, the v of velocity is what? Squared. That is why it is what? A scalar quantity. Normally, since it's possessed by a body in motion, it would have been what? Vector quantity, but it is a scalar quantity because the velocity present in it, it is what? Squared. Take note of that. So this is just the introductory part of vector and what? Scalar quantities. Now let me now give us rules or the various methods or principles we must note before we start solving questions on vectors. All right, now take note of this. Take note: vectors traveling towards the same direction are added. If I have this mass and you have two vectors traveling towards this direction, if this is maybe 50 Newton and this is 20 Newton. All right. The resultant of these two forces is simply 50 plus what? 20, and that will give me what? 70 Newton, because they are traveling towards the same direction, which is what? The eastward direction. But if they should travel like this, if one is traveling towards east and the other is traveling towards west, if this was maybe 100 Newton and here is 50 Newton, all right, what is the resultant of these two forces? It is simply 100 minus what? 50, and that will give me what? 50 Newton. That is because they are traveling towards different directions. And again, now we've gotten the resultant to be what? 50 Newton. Is it 50 Newton to the east or to the west? It is to the west, because the force traveling towards eastward direction is what? Bigger than the one traveling towards sorry, it is 50 because the one traveling towards westward direction is bigger than the one traveling towards what? Eastward direction. So please, the answer is what? 50 to the west. All right, so that is how it is. When they are traveling towards the same direction, we add, but when they are traveling towards different direction, we would subtract. But when they are inclined, when they are perpendicular to each other, when they are perpendicular to each other, when they are perpendicular to each other, an angle of 90 is what? Formed. When they are, one is going up and the other one is, this one is the vertical axis and this one is what? The horizontal what? Axis. An angle of 90, it is what? Formed. In this case, you will use what? The Pythagoras what? Theorem. We use the Pythagoras theorem when they are perpendicular to what? Each other. Take note of that. Now, when two forces are inclined at an angle to the vertical, when two forces are inclined at an angle to the what? The vertical. Look at, if I have one angle like this, if I have one, let me erase this one please, because of calculation sake. If I have one like this, and I have another one like this, and I have something like this, I can try to do it like this. Okay, let me extend it a bit. Now you have you have one force here, and you have what? One force, and you have this is what? The resultants. Now when these two forces are inclined at an angle to the vertical, this is the vertical, and this is the vertical force. When they are inclined at an angle to the vertical, the velocity is usually v equals what? V, this is I think, okay, this is the y-axis and this is what? The x-axis. This is the y-axis and this is what? The x-axis. Normally the x-axis is usually what? Horizontal, and you use what? Cos theta, and you use this the y is usually what? Sine theta. But now that it is inclined to the vertical, this rule does not hold. It becomes v. Okay, here becomes the v, this becomes v sine theta. That is to the x sine theta. Since the angle is to the vertical, you understand it better now. Now this is cos theta because it is y, and this becomes v equals v cos what? Theta. That is to the y and to the what? X. That is when the angle is inclined at the vertical region of it. But if you now have these forces inclining at an angle to the horizontal like this, I have, no, this is my x-axis and this is my what? Y-axis. If the angle is now inclined to the horizontal, look at it, this one was to the vertical, but this one was what? To the horizontal. Then this becomes V equals uh, Vx, or say Vx equals V cos what? Theta. It is cos theta because the angle is inclined at the horizontal what? Because this is a horizontal line and this is what? Vertical line. Then as to the y axis, it becomes V sine what? Theta. When two forces are inclined at an angle to the vertical, it is really Vs equals what? V sine theta, and Vy becomes what? V cos theta. But when the two forces are inclined at an angle to the horizontal, the normal rule follows. Vx equals V cos theta and Vy equals what? V sine theta. Take note of that. Please, most students, they take these two to be the same. They are not. Vertical is this, horizontal is what? This. Now, which one should I give us again? Now, okay, if I have something like this, if I have force 1 and force 2, of course, inclined at an angle of what? 90 degree. And this one is what? The resultant. The resultant of these two forces, which is the y-axis and the s-axis, becomes r squared equals what? Equals F12 plus what? F22. Or, if I don't do it like this, I'll say square roots. Here is y, right? That is velocity squared to the y region, then plus velocity squared to the x region, right? The both of them are the same, right? Just that this first one I used forces, all right, and second one I use what? Their axis, y and what? X axis. Take note of that. It is very, very important. Now, in some cases under this topic, which is vector quantities, we also apply the cosine rule and the sine rule. It is very, very important. The cosine rule and what? Sine rule. And this part is the part most students really do not take lightly, all right? If I have something like this, if I have an angle, let me use a better marker, please. If I have an angle like this, I have another one like this, all right? If I make here A, I make here B, all right, and I make here D, okay, C, as the case may be. An angle is here. Let me say here is my force 1, and here is my force what? 2. All right, you have A, B, C. All right, using the cosine rule, this becomes, okay, here is definitely your r, right, which is the resultant vector. You have r squared equals what? F1 squared plus F2 squared minus 2F1 F2 then cos theta. So this rule is what? Cosine rule. This place is an angle, this is resultant vector, and this is what? F2 and what? F1. This is what? The cosine rule. Then using the sine rule, this becomes, what angle is facing A and B? C, right? The angle facing A, let me use theta in this case. The angle facing A and B is what? C. So I'll say AB over sine C, is that not correct? Equals BC, that is BC over sine. What is the angle facing BC? A. Then equals AC. What is the angle facing AC? It is what? B. So I'll say sine B. Alright. So this is what? The sine rule. It is very easy. Just follow it step by step. Now, AB, you have them to be facing this angle, which is what? C. I'm using alphabet now. I've used, okay, let me just use sine theta. All right. And you have another one, BC, being faced by what? Angle, just like alpha sine. Then you have AC being faced by what? Sine B. So this is the cosine rule, and this is what? The sine rule. So that is for that. So since we've been able to understand this part, it is very important we commit it to what? Memory. That is for that. But if I now have forces, I have something like this. I have something like this. All right. Now this is F1, F2, F3, and what? F4. All right. F1, F2, F3, and what? F4. Now you have angles here. You have angles here. So you say theta 1, theta 2, theta 3, and what? Theta what? 4. Take note of that. So of course you know that this is the y-axis and this is what? The x-axis. That is negative x-axis, negative y-axis, positive y-axis, and positive y-axis. So you have negative x-axis and negative y-axis. You have positive y-axis and positive what? Y-axis. Take note of that. Now let us start solving questions. I believe all these formulas I've given us have entered into our cerebrum. So please, let's start solving questions. Okay. Don't forget the sine rule and the cosine rule. It is very, very important. Now, if I should give a question like this. All right, I have a question here. I have a question. So I'll just read it orally while you do the writing, okay? Let's write. Two forces whose resultant is 100 Newton. Two forces whose resultant is what? 100 Newton are perpendicular to each other. Don't forget the rule I gave. They are perpendicular to each other. Two forces whose resultant is what? 100 Newton. I told you this is what? The arrow, which is the resultant. 100 Newton to each other. If one of them makes an angle of 60 degrees with resultant, calculate its magnitude. Now, let one of the angle be what? X. Let one of the angles be what? X. So I'll put X. But they said that this X forms an angle of what? 60 degrees. I'll read the question again. Two forces whose resultant is 100 Newton are perpendicular to each other. If one of them makes an angle of, we don't know what the angle is, so you can make it X, make an angle of what? 60 degrees with resultant, calculate it what? Magnitude. Alright, they said sine 60 equals 0.8660. Said cos 60 equals what? 0.5000. Now, they gave us this to know how much we've really understood of vectors. Okay, vectors. Now, don't forget SOHCAHTOA. 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 Now, looking at what we have 100 Newton and we have what? X. And of course, we are using cos x axis, that is adjacent over what? Hypotenuse. Adjacent over hypotenuse. Which means that cos 60 equals cos 60 adjacent. Where is the adjacent? Is x, right? Then hypotenuse is what? 100 Newton. How do you see how easy it is? Just bring out your diagram, you understand it. Now S becomes 100 times what? Cos 60. From what they give us, x equals 100 times cos 60 from the question is what? 0.5000. X is equals what? 50 Newton. So they said one of the angles make up what? This, okay? I think two forces, resultant is dash dash dash. So that is how it is. That is question number 1, perpendicular to each other. So the next question is this. Write it out. A lorry travels, are you there? Right. A lorry travels 10 kilometer northwards. Okay, you have, I'll use another marker, please. Okay, a lorry, I have, because this is east, this is north, this is south, and this is what? West. They said a lorry travels 10 kilometer northwards. So I'll do north like this. Okay, north up. So I'll do it like this. That is going up 10 kilometer northwards. All right, 10 kilometer northwards and 4 kilometer eastwards. Eastwards. 4 kilometer eastwards. Then it said 6 kilometers southwards. So it's coming down, which is 6 kilometer south. Let me write at the back. 6 kilometer, that is coming down south, and 4 kilometer northwards. So 4 kilometers. Now they said a lorry travels 10 kilometer northwards and 4 kilometer eastwards, then 6 kilometer southwards and a 4 kilometer westward. To arrive at a point P, what is the total displacement? What is what? The total displacement. You have to like this, just bring it here. Then you have another one here. So this one is what? 4 kilometers. So that one is what? 6 kilometers. So how do you now deduce the final displacement? It is very easy. Where is the ball wiper just now? Yeah, it is very easy. This is what you're going to do. We have northeast and we have what? Southwest. Northeast, that is northeastern. East is what? East is what? 4. And that will give us what? 14 kilometers altogether. Alright? Northeast, that is 10 plus 4, you have what? 14. Then it said southwest, which means 6 kilometers plus what? 4 kilometers, and that will give us what? 10 kilometers. Now to now calculate the total displacement, it is 14 minus what? 10 kilometers. 14 kilometers minus 10 kilometers, and that gives us what? 4 kilometers. So this is the final displacement. It is very easy, just follow it step by step. So the answer is what? 4 kilometers. All right, now the next one is, we have another one here. Okay, you write it, a particle of mass, I don't know if I should write it on the board, I don't know, with time permits, me to do that. A particle, okay, let me just bring out the parameters. A particle of mass 100 or 10,000 gram is acted upon by forces. Like the forces now, you have 2 Newton, 4 roots 2 Newton, 6 Newton, and 8 Newton. A particle of mass 10,000 gram is acted upon by 2 Newton, 4 roots 2 Newton, 6 Newton, and 8 Newton. For angle of 30-degree, right? 45-degree, 60-degree, and 120-degree. Find the magnitude of each acceleration. Find the magnitude of each what? Acceleration. Now, which means that from this question, they said, so respectively is very important. There is respectively, which means that the first force here, that is force 1, is equals what? 2 Newton. And that means that the angle is what? 30-degree. Then F2 is equals what? 4 roots 2 Newton. And the angle is what? 45 degrees. Then F3, the third Newton is what? 6. And the angle is what? 60-degree. And the fourth force is what? 8 Newton. And the angle is what? 120-degree. Now, since we've been able to do this, now this becomes, you say, 2 to the x axis, which is actually the horizontal axis, and that becomes 2 cos 30 plus, is it 2 cos? Yes, that is 2 Newton, then 4 roots 2 cos 45 plus 6 cos 60, then plus 8 cos what? 120. So let's now check what is cos 30. Cos 30. We have cos 30 to be 2 times root 3. That's cos 30 is root 3 over 2, and this is 2. So 2 going to 2, I have what? Root 3 plus, okay, cos 45 is what? Cos 45 equals root 2. So this means 4 root 2 times root 2 over what? 2. Because cos 45 is root 2 over 2, and this is the Newton given. So 2 into 2. 2 into 4 is what? 2. Alright? So root 2 times root 2 is what? Root 4. But the square root of root 4 is what? The square root of 4 is 2. That means I now have it to be this place. Alright? 2 into 2, you have 2. Root 2 times root 2 is root 4. But the square root of 4 is what? 2. Which means 2 times 2, I have what? 4. So which means this place will now be what? 4. Are you following? Then plus 6 times cos 60. Cos 60. I have 1 over what? 2. Which means 2 here 1, 2 here what? 3. Which means I have what? 3. Then plus 8 times cos 120 is what? Cos 120 minus 1 over what? 2. So which means I have minus 4. Everything here is now what? Okay, plus that is minus what? 4. Good. Now I have root 3 plus 7, then minus what? 7, right? That is root 3 plus 4 plus 3 plus this. Then, so this plus this is what? 7. Is it? Okay, minus 4. Sorry, minus 4. That is root 3. This plus this is 7. Then plus times minus is what? Minus, then you have 4. So, 7 minus this is 3. So, root 3 minus, okay, I have 3 here. That is 3. Is it plus now? Yes, plus 3. So, root 3 plus 3 equals root 6. So which means that in this case, hope I'm not getting it wrong here. 7, I have 7. Then this I have it to be like this. So which means, okay, everything is, I think, minus 0. Yeah, minus 0 0.5. Minus 0 0.5. So you have minus 0 0.5. Minus 0 0.5. So then that is for cos. Now the next one is what? Sine. You know this x-axis is for, this cos is for the x-axis. Excuse me, then the y-axis is sine. Then to the y-axis, the same thing is applied. It becomes 2 sine 30 plus 4 root 2 sine 45 plus 6 sine 60 plus 8 sine 120. Alright, so sine 30 is what? Sine 30, 1 over 2. So 2 times 1 over 2. So I have everything here is 1 plus, then 4 root 2 times, okay, 4 root 2 times 45. Sine 45 equals, okay, I have 4 root 2 times root 2 over 2. Okay, so I will have the same thing here, 4, then plus sine 60 equals root 3 over 2, which means 6 times root 3 over what? 2. Alright, so this into this I have 3, which means that is 3 root what? 3. So 3 root what? 3. Then plus sine 120 root 3 over 2. That is 8 times root 3 over what? 2. Right? So 1, 4. So now I have 1 plus 4 is what? 5 plus 3 root 3. Then plus 4 root what? 3. Okay, in this case, I will not be having, okay, this plus this is what? 7. 7 plus this 11, that is 11 root what? 3. 11 root 3. Yeah, look at it. 5 plus this is what? 8. 8 plus 4, okay, 12. 12 what? 12 root 3, which means the x-axis is this, then the y-axis is what? This. Now, to not use Pythagoras, what am I supposed to like this? To not use Pythagoras theorem, what? Pythagoras theorem. Now, you have my x-axis is what? 12 root 3, and my y-axis is what? Minus 0 0.15, and this is what the resultant. You know, normally arrow is equals 0.5 squared. Now, the reason I don't put minus is because minus 0.5 squared is as what? It will give us positive value, which is what? 0.25. Then times 12 root 3 all squared. So I'll rub off this part. Let me just write it here. So this 0.5 raised power 2 is 0.25 plus. Now these two will affect everything here. It becomes 12 times 12. That is 144. 144 times these two, remove this one, times 2. Alright, so it becomes 144 times 2 plus 0.25. So I have that 288.25. So what is the square root of 288.25? Square root of 288.25. We have 17 approximately. 17 Newton approximately. Alright, so are we true? No. They said we should calculate the magnitude of what? The acceleration. The magnitude of what? The acceleration. Which means, but you know that force is equals m times what? A. Force is 17. Mass from the question is what? 10,000 gram. But we are not calculating a gram, we are calculating in kilogram. That means that we'll divide by what? 1,000. This into this. So I'm left with what? 10. Then A, so what I'm looking for, divide both sides by 10. Which means that A is equals 17 divided by 10. 17 divided by 10 equals 1.7. So please, that is the answer. That is the answer. Please take note of that. It is very, very important. Now, another question. Jesus. Another question. So just follow it step, which means that the final answer is what? 1.7. Okay. You do for the x, you do for the y. You now apply Pythagoras theorem. Now let us take two more questions. Two more questions. Oh God, excuse me, let me clean my face. Alright, so I have a question here. Let us solve this one together. I have what I'm giving here. I have AC, I have D, then an angle was given here as 125 degree. Then here an angle was also given. They said F1 is equals what? 10 Newton. Then F2 is equals what? 12 Newton. They said, then R is here, find the resultant. Find the resultant. This one is a bit long because we'll be applying the sine rule and the cosine rule. Let's go. Now using the cosine rule, I have r squared equals what? F1 squared plus F2 squared minus 2F1 F2 cos what? 1, 2, that is cos theta. Therefore, r squared is F1 is what? So you see 10 squared. 10 squared is what? 100. Let us not waste our time. Then this one is what? 12 squared. 12 squared is what? 144 minus 2 open brackets. F1 is 10 times F2 is what? 12. Then times cos 125. Then r squared is equals, this plus this is what? 244 minus this plus this is 120. 120 times 2 is what? 240. Then minus cos 125 is what? cos 125. I have minus 0.5736. All right. So r squared now is equals 244. There's minus here. It's minus. There's times before minus. All right. This is times, and this is cos what? 125. So minus times minus is what? Plus. Minus times minus is what? Plus. So 240 times 0.5736. I will have 137.664. So r squared now is equals 244 plus 137.664. I have 381.664. Alright, so that is not the final answer. You look for the square root of, therefore r is equals the square root of 381.664. Alright, the square root of 381.664. I have r to be 19.53 Newton. All right, 53 Newton. This one is what the cosine rule. Now we have not gotten the value of this angle. That's where we now apply what the sine rule, as I gave us initially. Now using the sine rule, now AC over what? What is the angle facing it? This. Sine 125, we had what? Sine 125. Sine 125. 0 point. Okay, let me just put it first. Sine D equals, then DC. What is the angle facing DC? Is this what? Sine A. Please take note, don't waste your time bringing out the third angle. The third angle is usually what? Neglected. We are always solving using what? Two angles like this. So you now have AC is the resultant, which is what? The arrow. And I have the resultant to be what? 19.53 over sine. Sine 125 is what? 0.81. Let me make it 82 approximately. Equals DC. DC is 10, then sine A. That's what we are calculating for. So let's do this. 10 times 0.82. 10 times 0.82 equals 8.2 equals, okay, you have 19.53 times sine alpha. So divide both sides by what? 19.53. So which means that sine A is equals what? 8.2. Is it 8.2? Yeah. 8.2 divided by 19.53 is 0.419. That's 419. Okay, to now look for the angle finally, you look for the sine inverse. The sine inverse of A. So A is equals what? Sine inverse of what? 0.419. The sine inverse of 0.419 is what? Sine 0.419. 24. I have that A is equals what? 24.77 degrees. So this is the answer. Don't you see that it is very, very short? Just follow it step by step. You understand it. So this is where the calculation stops. So let's take the last question. Hope it's recording. Yeah, it's recording. Let's take the last question for today. Then after this topic, I'll be taking us projectile. Okay, so let's take it, which is the last topic. The last topic. Look at the diagram on the board. You have, oh god, these markers are bagged already. So I have let's say this one is 3 roots 3 and 10 Newton 30 degree. This one is 60 degree. Newton. Don't forget this F1, F2, F3, and F4. Alright, so they gave us an angle for, oh god, where is that stuff? I think they gave us an angle. I think they said this one, they gave us F1, the angle for S1 as 0. That is, angle is what? 0. Then F3, what they give us as F3? The angle for F3, I've forgotten. Oh god, excuse me. They give us an angle for 3. Okay, 0. Okay, is it 0 and 90? That is F1 is 0, F2 is 30, F3 is equals 90 degree, then F4 is what? 60 degree. Now calculate their what? Resultants. Now we'll calculate for the horizontal component, which is the x-axis. I'll now calculate for the y component, which is what? The y-axis. Okay, the vertical component rather. Okay, F1 cos theta 1 is equal, F1 is what? 3 root 3 times cos what? 0. Root of 3 equals, okay, 3 root 3 times cos 0. No, 3 root 3 is what? Okay, then let me just break it out first. Cos 2 is equals what? 10 times cos 30. Then F3 is then cos, I think is 10 times cos 90. Then F4. Okay, now look at this. You know, I told this positive y, right? This negative y, this negative x, and this is what? Positive x. Now 4 for S4 is what? Negative. So you see minus 4x cos what? 4 is equals what? Minus, where is okay, where is the Newton now? I think they gave us the Newton just now. Yeah, 6 Newton. 6 Newton. So 6 Newton times cos 60. All right. So this is, everything here is 0 because cos 0 is same as 0. So 0 times everything is what? 0. Then equals Cos 30 is what? Cos 30. Cos 30 is cos 30. Cos 30 is root 3 over 2 times 10 times 10 times 10. So 2 here 1, 2 here 5. So that is now 5 root what? 3. So 5 root what? 3 equals cos 90 is what? Cos 90 equals 0. So 0 times 3 is same thing as what? 0. Then equals cos 60. Cos 60 equals 1 over 2. So minus 6 times 1 over 2. You have what? Minus 3. Minus what? 3. So cos. So now can I add everything together? You will say 0 plus 5 root 3 plus 0 minus what? 3. So you now have this is out of it. So hope I'm not. Are you sure this angle I got here is correct? So I was checking it just now. Into 30, okay. Don't know, sine 90. I don't know where I got this question from. I can't. Okay, I think I'll solve with what I have here. So I'll solve with what I have here. So from what we have now, so this is 5 minus this is what? 2. So I now have this one as 2 root what? 3. Yeah, because 5 minus 3 is what? 2. You now have what? Root 3. Now, so this one is for the x-axis. Now, let's calculate for the y-axis. So the y-axis, everything becomes what? Sine, sine, sine. So it means that we now have f1 equals, that's f1 sine theta 1 is equals, Jesus, excuse me. F1 sine theta 1 is equals 3 root 3 times sine 0. Then f2 sine theta 2 is equals 10 times sine 30. Then f3 sine theta 3 is equals, where is it? 3. Okay. That's 3 times sine 90. Then minus f4 minus s4 sine theta 4 is equals 6 times sine 60. All right, equals sine 0. Sine 0. Yeah. So everything here is 0. Sine 30 should be 1 over 2. I don't know. Sine 30, 1 over 2. Yeah. 1 over 2 divided by 10 divided by. Okay, that is 10 times 1 over 2. Okay, 5. I have 5 here equals sine 90. Sine 90 is 1. So 1 times 3 is what? 3 equals sine 60. Sine 60 equals, okay, you have 6 times root 3 over 2. Sine 60 equals root 3, okay, 1, 3. So I have 0 plus 5 plus 3 minus root 3, 3. So this plus this is what? 8. 8 minus 3, and I have that 5 root what? 3. So this one is for the y-axis. This is the y-axis. And this other one is for the what? X-axis. Now that is not the final answer. We use Pythagoras what? Theorem. Pythagoras theorem. So, which means we now have x-axis is 2 root 3, and okay, x-axis is 2 root 3, then y-axis is what? 5 root what? 3. So this is of course the resultant. So which means as arrow squared or arrow equals 5 plus, so now cos, now this times this 25, 25 times 3 is what? 75. This means 5 raised to power 2 is 25, then 2 cancel this root, you have 3, so 25 times 3 is what? 75, plus 2 times 2, I have 4, then 4 times 3 is what? 12. Yes, now 12. So which means that the square root of 89 is that not 8? Okay, 87. 87. So the square root of 87 equals okay. My calculator is not giving me the answer. That is root 87. My calculator is not set. It's repeating root 87. So whatever you get as roots, it is the square root of 87. That is, well, that will be the answer. So at this point, we'll call it a day on vector. Everything that vector has been treated. If you have more questions, you can try it yourself, or you can just put it on the comment section. I will do justice to it. Thanks for watching. Please subscribe.